Welcome to Sri Chaitanya IIT Academy. Today we will be discussing JEE Main Physics question paper that was held on 24th February, Shift 1. And please note that these questions are based on students' memory. Let us see question number 1. Now, this particular question, if two identical capacitor, once connected in series and once connected in parallel, then find ratio C1 by C2, that is, okay, C. So this is series, and we have C and C, let me suppose, then C effective will be C into C by C plus C. And about the parallel combination, and I have C effective will be C plus C, and here I get C by 2, and here I'm going to get 2C. Okay, now he is interested in the ratio, and if I take this as C1 and this as C2, now C1 by C2 is equals to C by 2 by 2C I have. Okay, now this will be C by 4C, and I'm going to get 1 by 4, and this is the right option. Okay, so we'll move on to the next question, please. Now, moving on to this, and this question is based on the Coulomb's law, and you find that this particular charge is negative. Other than that, all other charges are positive, and this will be governed by Coulomb's law, and F is equals to 1 by 4 pi epsilon naught Q1 Q2 by distance square. Okay, and about this particular distance, what we have, in fact, if the question says that electric field at center of the cube is, he's asking. So in order to find this particular distance from any of the corner, we need to use these distances. Okay, so now this will be root 2a, and this is a, and this particular distance, what I have here, if you calculate, now the distance will be, if I mark it as x, and this will be x is equals to root of root 2a whole square plus a square, and I'm going to get this as root 3a. Okay, so on doing this particular problem using Coulomb's law, you'll be able to get the option. The right one is first one. We'll move on to the next question, please. Now, in a transistor, if increase in emitter current is 4 milliamperes and corresponding increase in collector current is 3.5 milliamperes, find beta, he says. Okay, so emitter current he has given as 4 milliampere, and increase in collector current he has given 3.5 milliampere. Okay, so, and we'll be looking into current gain in common base connection, and that is delta IC by delta IE, and here I'm going to get 7 by 8, and beta, the current gain in common emitter connection is alpha by 1 minus alpha. Now I'll be substituting these values. Okay, so now I'll be getting 7 by 8 by 1 minus 7 by 8, and the answer I'm getting it as 7 here. Okay, next problem, please. Now he says, if W1 by W2, the width of the window, he means, is equals to 1 by 3, and it's given that amplitude is proportional to the width, find I max by I minimum. Now this width is amplitude given that width is given as amplitude, and for that reason, now if W1 by W2 is given as 1 by 3, I take amplitude 1 by amplitude 2 as 1 by 3. Okay, so I take a multiplication of x here. So A1 by A2, let me suppose that this is 1x by 3x, let me suppose. Then I max will be, as he is asking I max will be A1 plus A2 whole square, and I min, the minimum intensity will be A1 minus A2 whole square. And when I'm interested in the ratio, I'll divide one by the other. Now I'll be getting this as 4x whole square by, now this will be minus 2x whole square, of course, and I'll be getting this as 4 by 1. Okay, so now the right option will be the fourth one, please. I mean, third one. Okay, so let's move on to the next question. And if a small block of mass m is placed gently on capital M, when it is passing through its mean position, find its new amplitude of simple harmonic motion if initial amplitude is A. Now, from spring force, F is equals to minus Kx, and we have the centripetal force, F is equals to m omega square x. Now, I equate these two magnitudes only. I consider Kx is equals to m omega square x I get, and I'm going to get m omega square. Omega square is equals to, omega is equals to root k by m. I'm getting from here. We have v is equals to r omega, and I go for maximum velocity at the mean position. So v max will be amplitude instead of r. I've taken amplitude into omega. Now this is about the maximum velocity I'm speaking of, because at the mean position, it will be having maximum velocity. Okay, so omega value I'll be substituting. So now I'm going to get V is equals to A into, now root K by M. I have substituted the above equation, this one. Okay, so now amplitude will be velocity into root of M by K I get. Okay, now when the additional mass capital M is added, now capital M is added, when it is added, then it so happens that the new amplitude will be, now I'll be considering the basic mass, and I take, now this will be in this particular ratio, the new amplitude will be, okay, so this will take the V nu, A nu is equals to, I'll get m by m plus m V nu. Okay, so now I'm going to replace this V nu. Now V nu will be m by m plus m. Now A into root of m plus m by k. Now this is based on this particular equation, what I have calculated. On this, I did this calculation, go through it. Okay, so upon solving this, we are going to get the first one as the right option. Okay, we are going on to the next problem, please. Okay, so from given velocity time graph, which of the following is acceleration time graph? Now, I'll be concentrating on this particular part. When I concentrate on this particular part, it so happens that now this is velocity here, in fact, and this is time on x-axis. Okay, so if it is velocity and time, and I go for y is equals to mx plus c, and it has a negative slope. So in the place of y, I have this, and it has a negative slope minus m, and in the place of x, we have t, and I'll be going for the constant, and he is interested in acceleration, and for that reason, I differentiate with respect to t. Okay, so I get dv by dt is acceleration. I'll be getting minus m. Now this is acceleration, what I'm getting. And For the second part of the equation, I mean, second part of the graph, this one, I'll write a similar equation of a straight line, and this will be positive slope. And for that reason, I'm taking mt minus c, please. And you can observe this, okay? And again, I do the same differentiate with respect to t so as to get acceleration, and acceleration is equals to dv by dt is equals to plus m I'm going to get. So the meaning is we need to have initially a negative slope and then a positive slope. The magnitudes are same, but the negative and positive is the factor what we need to consider. And if that is the case, and this one is minus m here and plus m here, and this is the right graph, okay, the magnitudes are same. We'll move on to the next question, please. Okay, so the problem reads, two stars are rotating about their common center of mass. Find the period of revolution of mass m about center of mass. Now, I take the origin as this, and this will be d comma 0, and I go for the center of mass. Okay. Now, here we have the gravitational force of gravity is equals to m omega square. And I'll take the center of mass here, okay, xcm, and this is omega here, this is omega here, and I'll be going for m omega square, and center of mass will be 2md by 2m plus m, okay, and the gravitational force will be gm 2m by, of course, I have d square, and omega is equals to, we have 2 pi by t, and upon solving this, and you'll be getting t is equals to 2 pi root of d cube by 3gm. So this one, you are going to get the answer, and this is the right option. Okay, so we'll move on to the next question, please. And this one is a memory-based problem, and we are given with the relation between different moduli of elasticity, Y Young's modulus, K bulk modulus, the rigidity modulus N are given, and the answer for this is this one. Okay, so, and you need to, this is totally memory based. Okay, we'll move on to the next question, please. And this one, if you look into this, and you have circuit given, and he's asking the potential difference Vx minus Vy. What is the potential difference between these 2 points? Okay, so when we go for this particular potential difference, and we are going to get the current, and let me find the current here in this particular circuit. Now, the current is, in fact, I get V by R. Okay, so here now we have 6 and 4, and opposite polarity are there, and for that reason 6 minus 4, and the sum of the resistances, I'll be taking this 8 plus 2. Okay, so we are going to get this as 1 by, in fact, 2 by 10 I'm going to get. Okay, and where I apply the sum of potentials from here to here, so I'm going to get Vx plus 4 volts. Now we are going from negative to positive terminal, and for that reason plus 4 I have taken, and plus IR I'll take is equals to Vy. I put the potential at Y. Okay, so now Vx plus 4 plus I is 2 by 10 I've got. Okay, and the resistance is 8 here. Okay, is equals to Vy, and he's asking us to find Vx minus Vy. Okay, so Vx minus Vy, I need to transfer minus 4 minus 2 into 8 by 10. Okay. Now here we are going to get minus 5.6. Okay. So, and the first one is the right option. Let's move on to the next one. Okay. So now the problem reads, if work is equals to alpha beta square e to the power of minus x square by alpha kt, where k is Boltzmann constant. Now T is given as temperature, then dimensions of beta is asking. So now we'll be looking into the exponent part, and this exponent part should be a dimensionless quantity. And for that reason, I'm putting this x square by alpha kt is dimensionless, m0, l0, t0, and this will be equal to 1. Okay, this means that x square by alpha, x square by kt is equals to alpha I get. Okay, so x will be the distance, and this will have L square by K, and T is given as temperature, okay, is alpha. And I'm interested in finding the Boltzmann constant K, okay. So in order to find Boltzmann constant K, what I do is I take the help of V. So now this V is equals to root 3 KT by M. We have the knowledge of this. I'm using this. Now V square is equals to 3 KT by M I have. Okay. So V square M by 3T is Boltzmann constant K. Okay. So now I'll be finding this K from this. Okay. Now we have found alpha is equals to L square by KT. Now I mark this as equation 1, this as equation 2. I substitute 2 in 1. Okay. Now alpha is equals to L square by, in the place of Boltzmann constant K, I'm substituting V square M by 3T, and into T I have. Now this T gets off, of course. Now L square by V square. Now velocity square, that is, okay, into M I have. So this velocity is LT minus 1 I have. So I take LT minus 1 and M. And of course, this numerical 3 is not considered in dimensional analysis. And that's why I have avoided writing 3. Okay. So I'll be left with now L square and L square T minus 2. And this is M inverse, and L square gets off. Okay. So I get M inverse, and this is T raised to the power of plus 2. I'll be getting it. Okay. So now we got alpha value, and we need to look into beta because he's asking the dimensions of beta. So the question here says that work is equals to alpha beta square, and the exponential part is just a one dimensionless quantity. For that reason I put it. So I have work is force into displacement, and this force into displacement is force is mlt minus 2, and the displacement is L, is equals to alpha we have found here. Okay. M minus 1 and T raised to the power of 2 I have, and beta square we need to find. Now M L square T minus 2 by M inverse T square is equals to beta square I have. Okay. So now finally what I'm going to get is the option M square I'm going to get, and L square and T minus 4 I'll be getting is equals to beta square, and this upon taking the square root. So upon taking the square root, you'll be getting ml T minus 2 as beta, and which is, we have the first option. Moving on to the next question, please. Okay. Now here, the Zener diode is connected in circuit as shown. Find current in 2K ohm resistance. Okay. Now we have from Ohm's law, I is equals to V by R, and this will be, in fact, we have 5 volt across the Zener diode, 5 volt, and we have the resistance given 2K ohms. Okay, so in fact, we have a parallel resistance 2K ohms. Let's look into the current here. Okay, so now in 2K ohm resistance, now there will be 5 volt potential difference because these two are in parallel, and for that reason, so I'm looking into the current across this. So I is equals to V by R, and for that reason 2K ohms is 2 into 1000 ohm this is. Okay, now I'll be getting this as 2.5 into 10 to power of minus 3. Okay, so now 10 to power of minus 3 is milliamp. Okay, so and for that reason I have the first one as the right option. We'll move on to the next one, please. So now we are given AB is isothermal. Now this is isothermal we have, and this is isothermal we have, and BC is isobaric. Now we can see that pressure is constant. Okay, isobaric, and CA is isochoric, and volume is constant here, of course. Okay, find total work done in cyclic process. So this cyclic process, when we look into this, so we have for AB isothermal process, work done from A to B, the isothermal process, the work done is, in fact, we have from A to B, I get 2 P1 V1 log 2 as the work done in isothermal process. In fact, you will be getting log final volume by initial volume 2V by V, and then I'm going to get it as 2. Okay, that's why I've taken this. Now, work done from B to C. Now here volume is decreased, and for that reason, this will be minus P1 V1. Volume is decreased, and for that reason, minus P1 V1. And from C to A, there is no change in volume, and for that reason, C to A, the work done is 0. And the total work done on adding these above 3, I'm going to get 2P1 V1 log 2 minus P1 V1. Okay, so let me take P1 V1 common. I get 2 log 2 minus 1. Okay, now from ideal gas equation, I have, because this is given as nRT, okay, given in the question, I'll be choosing 2 log 2 minus 1, nRT 2 log 2 minus 1. Okay, so we have an option here, and the second one is the right option. We'll move on to the next problem. Okay, now in the next problem, a side of cube A is made from 6 identical sheets. If coefficient of linear expansion is alpha, temperature is now made T plus delta T from temperature T, then find change in volume. So from temperature T, he has changed to T plus delta T. And we have from thermal expansion, V2 is equals to V1, 1 plus gamma delta T. Okay. So when I open the brackets, I get V2 minus V1 is equals to V1 gamma delta T. And this is change in volume by original volume is equals to gamma delta T I get. Okay. Now gamma is 3 alpha delta T. So gamma is 3 alpha. So I have written this, and I'm interested in delta V. If I'm interested in delta V, and I need to cross multiply, and I'll be getting V into 3 alpha delta T. Now this is volume of a cube of side A, he says. Now volume of a cube will be A cube 3 alpha delta T. Okay, so 3A cube alpha delta T is the change in volume, and which is given as the first option. Okay, so there is small print mistake here, and it should be 3A cube alpha delta T. Next, please. So Now the problem reads, if intensity after passing through a Polaroid is 100 lumen, now 100 lumen, now this same Polaroid is rotated by 30 degrees about its axis, then find new intensity after passing through it. Now the new intensity after passing through it. Now, intensity is after passing through a Polaroid is 100 lumen. And for that reason, this 100 lumen is going to remain constant after passing through another Polaroid also. And for that reason, the second option is the right one. Okay, we'll move on to the next problem, please. Now, four particles each of mass 1 kg and equidistant from each other move along a circle of radius. Now, this should be radius 1 meter. Okay, so this should be meter, of course. Under the action of their mutual gravitational attraction, the speed of each particle. Now, mass is given as 1 kg and the radius is 1 meter. And we need to draw a proper circle and we have four particles. So let me concentrate on the four particles. And, I look into the distances and this will be 2r. And this I need to find, of course. And this I need to find. And this will be isosceles triangle. And this is r. And this will be root 2r. Now, because 1 is to 1 is to root 2. And the velocity, I take it as v. Okay. Now, this is, of course, 45 degrees. And for that reason, the forces that are acting on this particular mass, now this is one of the forces, and this is the other force, and this is another force. These are the three forces that are influencing this. Okay. So now these are gravitational forces, what I have marked. Okay. So I resolve them into components. And when I resolve this force into components, now this will be sine component. Okay. So sine theta, and this will be cos component, cos theta. Okay. So similarly, I need to do the same thing here. And this particular component will be f sine theta. These two are equal and opposite, they nullify, and the sum of the forces acting on this particular mass will be given by, F total is equals to, now this one I'm speaking this particular force, now F with 2r distance and plus F with root 2r distance. Okay. So now this, I should have written F with root 2r distance and plus another F with root 2r distance. And when I look into this, now this will be GMM I get. So GMM by distance square will be 2r whole square plus, now this will be GMM by root 2r whole square, and I'll be considering cos 45 here plus GMM, another similar term I'm going to write root 2r whole square cos 45. Okay. So, and this is, I need to use the centrifugal force here, and this is mv square by r. Okay. So now this, I'm taking this as mv square by r here. Okay. So I need to solve for this. When I solve, I'm going to get v, and the option for this, in fact, when you estimate the values, you are going to get this as the second one. Okay. So on solving this equation, you are going to get the second option. Okay. We'll move on to the next question, please. Now here he has given choose the correct options, and he has given adiabatic, isothermal, isochoric, isobaric. Okay. Now, which is the right option? This is match the following what he has given, and this the now for adiabatic process heat content is constant. Okay. For isothermal the temperature is constant. Okay. So isothermal temperature is constant. For isochoric, of course, volume is constant. And the other follows, and we are going to get the first option, please. We'll move on to the next question. Okay. And relation between radius of curvature and focal length of a convex mirror, he's asking. It's a straight question, and this is F is equals to R by 2. We don't need to go for any further uh, discussion on this. Okay, F is equals to R. Next question, please. Okay, so here the problem reads I1 is equals to moment of inertia of ring. So moment of inertia of ring. Now I1 will be, now ring about its diameter, he says. Now about its diameter, it will become mr square by 2. Now about the diameter of a ring, I need to calculate. Okay, so natural axis is mr square, but now about the diameter, he says I2 is moment of inertia of disk of mass m and radius r through central axis perpendicular to the plane of the ring. This is natural axis he's speaking of. I2 is equals to, I'll be getting it as mr square by 2 for a disk about the natural axis. Now, I3 is moment of inertia of solid cylinder, mass m and radius r about its axis. Now, this is again natural axis. Now, this will be about its axis. Now, when we speak of its axis, now this will be the axis. And for that reason, this will be mr square by 2 for a disk, whatever the value what we get, that will be obtained. So I for moment of inertia of solid sphere through its diameter, he says. Now for solid sphere, it is 2 by 5 mr square. Now about its diameter. And when we look into these substitutions into various options that are given, and we are going to get the first one as the right one. Okay, so we need to go for the various options. So check for that. And when you substitute, you are going to get the first one. Okay, move on to the next question, please. So this 19th one, he has given spectral lines of hydrogen atom, and n is equals to 6, and various spectral lines are given here. And ABC he is speaking of, and he is speaking of A. Now A is from infinity to transition from infinity to the first principal quantum number, that is first energy level. Now this will be series limit of Lyman, please. Okay, so from fifth to second transition, now this will be about the Balmer, in fact. Okay, so and from fifth to third one, Lyman, Balmer, and then comes Bastian, and that is the second line of Bastian. This will be second line of Bastian, Lyman, Balmer, Bastian, and hence this would be the right option. Okay, I hope you got it. We'll move on to the next question, please. Okay, so now he says the de Broglie wavelength of proton varies inversely with linear momentum. Okay, lambda is equals to h by p. And statement 2 says lambda increases, energy and momentum increases. No, in fact, momentum, if lambda increases, we have inverse proportionality. Lambda increases, momentum should decrease. Okay, so and same is the case for energy, because we have kinetic energy is equals to p square by 2m, and I have 2m ke is equals to p, and this is under root. So lambda is equals to h by root 2m ke I have, and for that reason, it so happens that as lambda increases, ke should decrease. And for that reason, we have statement 1 is true and statement 2 is false. We'll move on to the next question, please. Okay. So now a 220 volts AC supply is given to the primary transformer. So primary transformer, and as output, so and as output of 12 volts DC is taken out using rectifier. If secondary number of turns was 24, find number of primary turns. Okay, So now, in fact, we have the transformer ratio. Now, number of turns of primary by number of turns of secondary is equals to, now whatever potential difference we have across primary, okay, by the potential difference across the secondary. Okay, so now we have n primary by 24. Okay, now the secondary is given as 24 here, and that's why I've mentioned it. Okay, so now the primary is given 220, and for that reason I put, okay, and now the other one is 12 volts, and here you are going to get NP is equals to 440, please. Okay, so 440 volts you'll be getting here as the answer. Okay, at 440 turns. Okay, we'll move on to the next question. So a vertical cross section of plane y is equals to x square by 4. Coefficient of friction is 0.5. Find maximum height at which particles can stay in centimeters, he says. So I have y is equals to x by 4. Okay, and from this I get 4y is equals to x square. Now implies x is equals to under root 4y. Okay, and for this, what I do is coefficient of friction he has given. Coefficient of friction is tan theta. In fact, in terms of trigonometry, we have the coefficient of friction mu is equals to tan theta, and this stands for dy by dx. And for that reason, what I do is I'll differentiate this first equation. Now, dy differentiating with respect to x, dy by dx is equals to, I get 1 by 4 2x. Now I'm going to get it as x by 2. Okay, so now dy by dx is, we have got this. In fact, coefficient of friction is mentioned here as 0.5, and he says that it has to stay there. If it has to stay there, and dy by dx value 0.5 should be greater than or equal to x by 2. Now this I have replaced here, and x by 2 I have taken as it is, and x I'll be getting this as 0.5, and I move on to the value. I substitute x here. When I substitute, now 0.5, this is 1 is, and I put this 1 is greater than or equal to x, and this is 1 is greater than or equal to 4y. I square on both sides. 1 is 4y, and I'm going to get this y is equals to, in fact, 1 by 4 is greater than or equal to y. I'm going to get. Okay, now this will be 1 by 4 in centimeters. He is asking, this is in meters, and I'll be getting this value in centimeters as 0.25 meters or 25 centimeters, please, will be the answer. Move on to the next question. Now here, find out minimum force required to stop block from falling, given G is equals to 10 meter per second square. Now, the friction force is equals to mu n we have. Now, this coefficient of friction, he has given it as 0.2. Okay. Now, the force, what he has given, this is normal reaction, what we have is equals to F. And, in order to have the force required to stop the block. Now, if this is the case, now weight should be equal to the friction force, and this will be mg is equals to 0.2 F. Now, I'm supposing this as force F. Okay. And in this case, what I get is he has given the mass as 0.5 and G is given as 10, and into 10 is equals to 0.2 F. I'm getting here. Okay. So now I get 0.5 into 10 by 0.2 is equals to F. And I'm going to get this value as 25. Okay. We'll move on to the next question, please. So here, two identical particles of same mass are shown just before collision and just after collision. Then V1 by V2 he's asking. So we will look into the principle of conservation of linear momentum. Now, principle of conservation of linear momentum. Okay. Now, along y-axis, I'll take. Okay. So Py of first mass plus Py of second mass. Now, this is before collision is equals to now of first mass. Now, momentum y component of first mass and momentum y component of second mass, and this is after collision. Now this two is after collision and this one is before collision. Okay, so if I consider now there is no velocity along vertical direction, so this is zero in fact velocity, and here also same is the case, velocity component is zero, and for that reason for this I'm going to get 0 plus 0 is equals to, now about the y component I'll be getting v1 cos 30, and here I will get v1 sin 30, and about this v2 cos 30, and I'll be getting v2 sin 30. So we are concentrating on y-axis, and for that reason, I'll be considering these two, v1 sine 30 and v1 cos 30, and we are given with mass m here. Okay, so mass m is given, and for that reason, I will consider this as m v1 sine 30 and minus, because this is downward, that's why I've taken minus m v2 sine 30. Now here I can cancel these two, and I will be getting this one as v1 sine 30 is equals to v2 sine 30. Okay, now v1 by v2 will be equal to 1. Okay, so we are getting the answer as 1, please. Okay, we'll move on to the next question. Now we are given with I is equals to 20t plus 8t square, and find charge flowing during 15 to 0 to 15. He's asking us to find charge flowing from 0 to 15 seconds. Now this should be seconds. Okay, now I is given as 20t plus 8t square. So the question itself says, and for that reason, I take this I as the charge by time, okay, is 20t plus 8t square. The clue itself in the question itself, the clue is in the question itself. So dq is equals to 20t plus 8t square. Now this is dt, and I integrate it within the limits 0 to 15. So integrate it within the limits 0 to 15, the time limits. Okay, so 0 to q, this is okay. I'm going to get delta q, or q, the charge flowing, the magnitude of the charge flowing. So now I can say that this will be magnitude of the charge flowing will be 20 t square by 2 plus 8 t cube by 3, and of course within the limits 0 to 15, the time limits is given, t is equals to 0 to. Now when I substitute this, I'm going to get this as 11250 coulombs. Okay, so this will be the correct answer I'm getting. Okay, so hope you got. We'll move on to the next question, please. Okay. A 100 kg block can be lifted by placing a mass m on a piston hydraulic lift. If diameter of piston placed at one and one end, it should be is increased by 4 times and that of second piston is decreased by 4 times. Now same mass M is placed at piston, then how many this should be? Now this is how, okay, how many kg weight can be lifted up for the new setup is the question. Okay, we'll be employing Pascal's law. Okay, so now this will be, in fact, F1 by A1 is equals to F2 by A2. I'll be employing it and I'll be getting the initial stage because 100 is given here. Okay, 100 into G by A1 is equals to mg by A2. Okay, now this is mg by A2 and this is in the equation 1. Let me mark this. Okay, so now what I have is he's asking for a change in the next sentence. Diameter of the piston placed at one end is increased by 4 times. Now diameter is increased by 4 times. Area is pi d square by 4. Now I need to go for squaring of this. Okay, and for this I need to put mg 4 square A1 because this is 4 times. That's why I've taken, okay, and mg. Now this is decreased by 4 times. Now this will be decreased by 4 times and this will be divided by 4 square. And when I go for the second equation, this one, now the interest is to calculate capital M value here. Now, when we go for this calculation of capital M value on taking the ratio of this, when I divide 1 divided by 2 and subsequently calculating this, in fact, I'll be getting the M value as 25600 kg. Okay, so this will be on dividing 1 and 2 equations, you'll be getting this capital M as 25600 kg, and this one will be the right answer. Please, we'll be moving on to the next question. Two planets are resolving is about planet with, no, this is revolving about planet with T1 by T2 is equals to 1 by 8. Find the ratio of angular speed. Now we have T is equals to 2 pi by omega. Okay, so now T1 by T2 is given as 1 by 8. Okay, and I have T1 will be and T2 is equals to 2 pi by omega 2. Now he's asking the ratio of omega. Now I substitute this 2 pi by omega 1 by 2 pi by omega 2 is equals to 1 by 8. Now I can conveniently cancel this. Now I get omega 2 by omega 1 is equals to 1 by 8. And he's asking omega 1 by omega 2 and we need to invert and this will be 8 will be the answer for this. So we'll move on to the next question, please. Now he says an electromagnetic wave is propagating in medium mu r is equals to epsilon r. Relative permeability and relative permittivity are given as 2. If speed of light in the medium is 3 x into 10 to the power of 7 meters per second, find the value of x, he says. So velocity of electromagnetic wave in any medium is given by root of, and this will be 1 by mu naught epsilon naught. Now this will be 1 by root of mu naught epsilon naught. So root of mu r epsilon r. Okay. Now this is velocity of light. What we have 3 into 10 power 8 meter per second. and we are given with these two values. Now this is 2 into 2. Now I'll be getting 3 by 2 into 10 power 8. I'm getting this value. So now I'll be getting this as 1.5 velocity in the medium is equals to 1.5 into 10 power 8. And he's asking 10 power 7 multiple. So 1.5 into 10 power 7 into 10, I get 15 into 10 power 7. Now 15 is the right answer. We'll move on to the next question, please. So in the next question, what he has given from modulation chapter, the communication chapter. So Vm is equals to 20 sine 100 pi t plus pi by 4. Vc is equals to 80 sine pi to the power of 4 pi t plus pi by 6 he has given. For amplitude modulation wave, find out percentage modulation index, he says. Now, percentage modulation index is, now here I need to consider amplitude of Vm, and this is amplitude of, okay, and the amplitude of C wave, the carrier, okay. So this one, so I have to consider this, and this will be into 100, okay. So now I'll be getting it as 20 by 80 into 100, and this is 4 times, and I'll be getting it as 25%, please. And this will be the right answer. So we'll move on to the next question. In AC series RLC resonant circuit, resistance R is equals to 6.28 ohm. Okay. So frequency 10 megahertz, and self-induction L is equals 2 into 10 to the power of minus 4 Henry is given. Quality factor he is asking. Okay. Now we have quality factor is equals to omega L by R. Okay. So now omega is 2 pi frequency into inductance by R. And when I substitute the quantities that are given here, okay, 2 pi and frequency is given as 10 megahertz, and this is 10 power 6, and L is given as 2 into 10 to the power of minus 4, and the resistance is given as 6.28, and pi is equals to 3.14. We have the knowledge of this, and from this, when you calculate, you are going to get this quality factor as 2000. Okay. So now this brings us to the end of the session, and all the best for you students. And again, I insist on that these questions are memory based from the students' memory. We have collected these questions. Thank you. All the best to you.